Welcome to the channel of Advanced Mathematics to learn topic of Algebra. In this topic, I will cover subtopic number 2 on exponent. I divide this subtopic into 4 parts. Part A will explain meaning of exponent. Part B will explain laws of exponent. Part C will explain graphs of exponent. And part D will explain application of exponent in real life. Okay, let me begin with part A, which is meaning of exponent. First, exponents have the same meaning. Exponents have the same meaning as powers, as well have the same meaning as indices. By definition, exponent is a short form to indicate 2 times a number or a variable has to be multiplied by itself. Is a short form to indicate 2 times a number or a variable has to be multiplied by itself. This definition tells us a number or a variable which is being multiplied by itself many times can be expressed in a short form with help of exponent. For example, number 7 is being multiplied by itself 4 times. I can write this expression in a short form with help of exponent as I write the number that is being multiplied by itself 4 times, which is 7. And this 7 is a number which is being multiplied by itself 4 times, is known as a base. And at the top of 7, I write 2 times for 7 to be multiplied by itself, which is 1, 2, 3, 4. And these 2 times which I write here is a power, or as well known as index, as well known as exponent. So, how to read this short form? How I can read the short form? The short form 7 at the top is 4. I can read this as 7 raised to the power 4. Another example. A variable y is being multiplied by itself 6 times. 1, 2, 3, 4, 5, 6. As well, I can write this expression in a short form with help of exponent as y. This variable y is being multiplied by itself 6 times, and this variable y is known as base. And at the top of variable y, I write 2 times for this variable to be multiplied by itself, which is 1, 2, 3, 4, 5, 6. Here is 6. And this 6 is known as power. As well, I can read this short form, which is y at the top 6 as y raised to the power of 6. Okay. Let me continue with part B. Part B explain laws of exponent. When these exponents are used for mathematical equation, they follow certain set of laws which make this equation easy to solve and simple to understand. Part B, laws of exponent. And the following are set of laws which you get as on the proper way of using exponent in different types of equation. And the first law is product law of exponent. According to product law of exponent, it states that when we multiply two numbers with the same base, then we add exponents. Product law of exponent states that when we multiply two numbers with the same base, then we add exponent. For this law to be valid, two numbers must have the same base in order to add exponents. For example, 2 raised to the power of m times 2 raised to the power of n. This is equal to 2 raised to the power of sum of m and n. Example, 6 raised to the power of 4 times 6 raised to the power of 6 is equal to 6 raised to the power of, in brackets, 4 plus 6 is equal to 6 raised to the power of 10. Okay. Let me continue with second law of exponent. which is quotient law of exponent. Quotient law of exponent. Quotient law of exponent states that we divide two numbers with the same base by subtracting exponents. Quotient law of exponent states that we divide two numbers with the same base by subtracting exponents. This law is valid when two numbers have the same base. In that case, we divide two numbers by subtracting exponents. For example, 2 raised to the power of m over 2 raised to the power of n. This is equal to 2 raised to the difference of m and n. For example, three raised to the power of 4 over 3 raised to the power of 2. This is equal to 3 raised to the power of, in brackets, 4 minus 2, which is 3 raised to the power of 2. Okay, let me continue with said law of exponent, which is power of product law. Said law of exponent is power of product law. According to power of product law, it states that in brackets a times b all raised to the power of m, this is equal to a raised to the power of m times b raised to the power of m. For example, in brackets 6 times 9 raised to the power of 4. This is equal to 6 raised to the power of 4 times 9 raised to the power of 4. Okay, let me continue with fourth law of exponent, which is power of quotient law. Power of quotient law. According to power of quotient law, it states that in brackets a over b all raised to the power of m, this is equal to a raised to the power of m over b raised to the power of m. For example, 6 over 7 all raised to the power of 9. This is the same as 6 raised to the power of 9 over 7 raised to the power of 9. Okay, let me continue with fifth law of exponent, which is fifth law is reciprocal law. Can a number have a negative exponent? The answer is yes. And a number with a negative exponent means the given number is a decimal number. And in exponent, negative sign tell us a reciprocal. For example, 2 raised to negative m. This negative tell us to find the reciprocal of 2 raised to the power of m. This is equal to 1 over 2 raised to the power of m. As well, a raised to negative m, this means negative tell us to find the reciprocal of a raised to the power of m. 1 over a raised to the power of m. As well, 10 raised to the power of negative 2, this means 1 over 10 raised to the power of 2. Okay, let me continue with the sixth law of exponent, which is fractional exponent. Fractional exponent. A number whose power is fraction is known as fractional exponent. For example, 2 raised to m over n. 2 is a number whose power is a fraction, which is m over n. And this fraction is what we call fractional exponent. And m is a denominator of this fraction. No, m is numerator of this fraction, and n is denominator of this fraction, m over n. And in fractional exponent, m is a power of the given number, and n is nth root of the given number. So, when I write 2 raised to the power of m over n, this is the same as to write nth root of 2 raised to m, or is the same as to write nth root of 2 altogether raised to m. For example, 2 raised to 3 over 2, this is the same as to write square root of 2 raised to the power of 3, or is the same as to write square root of 2 in bracket raised to the power of 3. Okay, let's look on seventh law of exponent, which is zero exponent. Zero exponent. Any number power 0 is equal to 1. A power 0 is equal to 1. 10 power 0 is equal to 1. C power 0 is equal to 1. Therefore, any number power 0 is equal to 1. Okay, let's look on some example concerning laws of exponent. Simplify. A raised to the power of n times b raised to the power of m times 1 over, in brackets, a raised to the power of 2n times b raised to the power of 2m. Solution. I have this expression a raised to the power of n times b raised to the power of m times 1 over, in brackets, a raised to the power of 2n times b raised to the power of 2m. I can write this expression as a raised to the power of n times b raised to the power of m times, I use reciprocal law to write this term in another form as 1 over a to the power of 2n with reciprocal law is a raised to the power of negative 2n, and 1 over b raised to the power of 2m is the same as b raised to the power of negative 2m. This is the same as a raised to the power of n times a raised to the power of negative 2n times b raised to the power of m times b raised to the power of negative 2m. When we multiply two numbers with the same base, we add exponent. When we multiply two numbers with the same base, we add exponent. This is the same as a raised to the power of n plus negative 2n, which is negative n, times b raised to the power of m plus negative 2m, which is negative m. This is answer as well. With help of reciprocal law, you can write this as 1 over, in brackets, a raised to the power of n times b raised to the power of m. As well, this is the correct answer. Note, as well, you can use quotient law of exponent to simplify this expression. Okay, thank you.